Good day everyone, and today we're going to solve another problem involving antiderivative. So what we have now is the integral of x plus 3 divided by the square root of 5 minus 4x minus x squared dx. So the first thing we notice here is we have a quadratic expression inside the square root. So we will complete the square first to simplify this. Let's rearrange the terms inside the root. So this will become negative x squared minus 4x plus 5. Factor out the negative sign from the first two terms. So this will become negative quantity x squared plus 4x, then we add 5. Now, after factoring the negative sign, we can now complete the square for x squared plus 4x. So, half of 4 is 2. Then we square it and we get 4. So rewrite this as negative quantity x plus 2 squared minus 4. Then we close the bracket and add 5. We can distribute that negative sign. So this will become negative quantity x plus 2 squared. Then this will become plus 4 and then plus 5. After distributing the negative sign, we can simplify this by combining our constants. So the inside of our root simplifies to 9 minus the quantity x plus 2 squared. Next is we adjust the numerator. What we have now is x plus 3. We can rewrite that as quantity x plus 2 plus 1. So it lines up perfectly with our completed square. Now, we split this into two separate integrals. The first part is the integral x plus 2 all over the square root of 9 minus x plus 2 squared dx plus the integral of 1 over square root of 9 minus x plus 2 squared dx. But first, let's solve the first integral first. We can use substitution here. So we will use v and then we will equal it to 9 minus x plus 2 squared. So the derivative of this dv is negative 2 times x plus 2 dx. So we only need x plus 2 dx here. So we can divide both sides by 2 to cancel out this. So we will end up with negative dv over 2 is equals to negative x plus 2 dx. So we can now substitute this back into our integral. We'll clear this out first. So this integral becomes negative 1/2 times the integral of v raised to negative 1/2 dv. So applying the power rule, this simplifies down to the negative square root of v, or negative square root of 5 minus 4x minus x squared. Now, for the second integral. This matches our standard rule for arcsine. The integral of 1 over square root of a squared minus u squared du is arcsine of u over a. Here u is x plus 2 and a is 3. So this becomes arc sine of the quantity x plus 2 over 3. So we can combine both results together of both the first and second integral. So this will give us our final answer. After combining, our final answer should become negative square root of 5 minus 4x minus x squared plus arc sine x plus 2 over 3 plus the constant of integration. So this right here can be your final answer.